Welcome back to the Matt Podcast. I'm your host, Matt Turck from FirstMark. The following is a conversation with Sharon Zhou, the CEO of Lamini, a very interesting enterprise LLM platform. We talked about the state of the art in enterprise AI, including fine-tuning.
I almost view the future of a world where we will get to continual fine-tuning, continual inference, and continual requiring that integration, that bridge between the two, because they will both be happening at very fast speeds.
The commoditization of inference.
My view of inference today, from a market perspective, startup market perspective, is that it's a race to the bottom today for cost.
The challenges with AI agents.
There is a gap between what it can do and those goals and potential fantasies. I think bridging that gap is probably an important piece of it. And at the end of the day, the most computationally expensive, the most important piece of that agent is the LLM.
As well as the groundbreaking work Lamini is doing in memory tuning in order to reduce hallucinations.
We want to drop the speed of doing memory tuning significantly, because today when people are running RAG or prompt engineering, those are search. It's like keeping the AI frozen and fixed.
Now, in addition to being a great AI founder, Sharon has done a lot of teaching, both at Stanford and on Coursera, where she teaches very popular generative AI courses. As a result, one of the things I really love about all my chats with Sharon, including this one, is that she explains a lot of complex concepts incredibly clearly, and there's always a lot to learn. Please enjoy my conversation with Sharon. Sharon, welcome back to the Matt Podcast. You and I did a great episode just a few months ago, I guess last year, but in the AI world, a few months is like 7 years on Earth or something. So let's do it again this time. So we're going to talk about Lamini, we're going to talk about the market, but let's stop here and there to talk about specific concepts that may be interesting to a broad audience that's interested in AI, but may not be super into the details, into the technical stuff. So let's do that like we did last time.
Awesome.
Sounds good? All right.
Thank you so much for having me back.
Yeah, absolutely. So maybe let's start at the high level. I'm curious from the perspective of a founder who's very much in the proverbial trenches of AI, specifically enterprise AI, day in and day out. What's the current mood in July 2024 as we record this? It sort of feels like the AI hype is slowing down a little bit. What are you seeing in the market? How are customers responding? What are they doing? What are you seeing?
It turns out having a non-negative margin is an interesting thing, isn't it?
Who knew?
Okay, so a few things. I think one is from the customer perspective, from enterprises. We sell to enterprises. I think what's going on there has been extremely exciting. But also, I think there's been met with, these enterprises are actually starting to structure their organizations, having centers of excellences who are tackling this problem, being able to onboard different products internally. And I would say the sentiment is, hey, we've tackled the shallow use cases. We've been able to put some of those in production, but now we're thinking about what's next. Is this technology really only going to help me compose email? Or is it going to do something a little bit more? Is it going to help me leapfrog my industry, or is something in between that? What are the steps I need to take to get there? And so I'm starting to see deeper use cases. I'm starting to see people tackle those deeper use cases across their both data science and engineering and even infrastructure teams.
Yeah, so, what was an example of a deeper use case? So the shallow use cases, so that's like email, search, I guess, that kind of stuff.
Yes. Things that, for every model ping, it might not be necessarily immediate ROI. So I was talking to a large insurance company today, this morning, and they said, well, we have all of these essentially field reps, and they have extremely high turnover there, and we want to be able to train them up, right? We want to be able to train them up very effectively, and it needs to be grounded in these real facts about our business. And right now, we have these interesting demos. We have it kind of in demo land, but it's not in a place where we can realistically deploy them. We're not in a place where it's actually affecting thousands or tens of thousands or even hundreds of thousands of people. That's like one step deeper. And then another step deeper is thinking about, okay, well, let's just think about drug discovery, right? Like drug discovery, it takes a decade with a 90% failure rate today. But imagine if a company could pull that in and do, only 30% failure rate in 1 year. Like that would be a dramatic improvement, and that would be very, very interesting. That would be a true leapfrog where this company would be completely shatter that field, right? Like, because you would succeed at a completely different time scale and at a completely different failure rate. So I think that is like that. I think that future is coming, but it's not necessarily coming, as fast as ChatGPT entered everyone's phones and made it possible for us to send a text message and be able to get some form of an intelligent answer back.
Yeah. So what are big enterprises doing currently? Are we still in a stage where they brought in the consultants, they build the center of excellence? I mean, what are they doing, and what would you recommend they do to move as fast as they need to on generative AI?
So one thing that they've already done, I see, is I think compute infrastructure has been laid out more in place. I think budgets are there. I think the next thing around organizational structure that's extremely important that I think people don't fully realize, which is relating the technical piece of building out a successful model with the development piece of this model. And what I mean by that is generative AI is famously very hard to evaluate. We have no idea what's good, better, best, unless someone who's an expert in understanding that use case can tell you that, right? Like I can't tell you a medical, generative AI, LLM, generative AI model is actually that good because I'm not a doctor, right? I can tell you when it's at toddler teenager stage, but by the time it's getting an MD, I'm out. I'm not there. So being able to have those people sit closely with the development teams actually accelerates those use cases much more quickly. And that becomes an organizational problem. That becomes a very, very big difference I see across some enterprises where those teams are closer together, so those use cases can get out much more quickly. And then other enterprises where those are much more disjoint today, so they need to reorg to be able to actually get those closer together in order to deliver those applications. And I think that's why, realistically, we've seen many more code agents and applications around code, maybe Texas SQL. We've seen that a lot because the developer can also evaluate the outputs, right? They are the one and the same person. And so that makes development much faster because, again, that is a famously hard, difficult problem in generative AI from back in the research days. That was my PhD dissertation, actually, to today for realistic applications.
Very interesting. And what are you seeing, again, for enterprise customers in terms of let's just bring in OpenAI, on top of Azure or whatever to do this use cases versus, let's play with open source, our own models, and how's the thinking evolving?
Yeah, so I think it's pretty clear that it's going to be a hybrid world, right? And I think the general purpose models of the world are very good at these quote unquote shallower use cases that aren't necessarily business specific. Right? They're not necessarily going to be your proprietary model or heavy proprietary differentiation using AI. But they are going to be important to composing email, maybe writing certain types of basic code that aren't relevant to deep code bases that are very custom. So I think that will always be there, and that will always there will always be a best general purpose model, whether it be OpenAI's or Anthropic's or Google's, et cetera. And then I'm starting to definitely see a shift of, okay, well, this is great. This is an absolutely amazing technology. We've gotten to, develop advanced RAG and prompt engineering solutions on top of it. But it's still not enough. These models, when they're general, they're optimizing for what's known as generalization error, or the average error across all examples it sees on the internet. And as a result, it's pretty good at everything, but it's perfect at nothing. And despite our flaws, Matt, you and I were actually perfect at some things.
Are we?
Yes, I remember your name. You remember mine, presumably. Yes. And your own birthday, maybe. And maybe revenue number last quarter. I remember the liability number in my insurance claim, for example, if I were an insurance company. So I want the LLM to remember these facts with crisp accuracy, right? With factual accuracy where there's no alternative at all. And that means being perfect at some things. That means being perfect at recalling, whether it be a column in my SQL table or again, that revenue number in my earnings report. That is incredibly important for the reliability of these models. And so slightly right is not the same as right for these facts.
Yep.
And that is, that is where I think the next frontier is of, okay, well, now we've been able with memory tuning, which is what I've been working on, to remove those hallucinations, to remove that and actually get these models from, not necessarily being general for everything. And instead of being pretty good at everything but perfect at nothing, to be actually perfect or near perfect at some things and still pretty good at everything else.
Yep.
And I think that's where we're going. And I think that's extremely relevant to the enterprise.
Yeah, great. All right, so memory tuning is definitely something I want to spend a good amount of time on in the discussion. Maybe for anybody listening to this that didn't listen to the prior episode, which they really should do.
Yeah, why not?
Where we describe, your very fascinating, personal background and all those things.
Yeah.
Maybe a quick reminder on what Lamini does, like the 30-second pitch.
Okay, yeah. 30-second pitch. We're an integrated inference and fine-tuning platform for enterprises to be able to run factual LLMs, so essentially LLMs that don't hallucinate on their proprietary data within their secure walls. So we can deploy on-premise, air-gapped, no internet sites, so in the most extreme cases with extremely high security.
Okay. Okay. Awesome. Very good. So since you and I last caught up, one big evolution is that you are now offering inference. So when we first talked, you were very focused on fine tuning, which is part of the training world. Yeah. And you now added like the other side, which is inference. And maybe I said up front, like we'll define a bunch of things. So like for anyone that's not super in the weeds of AI, what is inference?
Inference is when you run the model. When you send ChatGPT a text, you're running inference. So oftentimes we're running inference of the model. We offer inference now. It had always been bundled. I almost view the future of a world where we will get to continual fine-tuning, continual inference, and continual kind of requiring that integration, that bridge between the two, because they will both be happening at very fast speeds. But essentially, my view of inference today, from a market perspective and startup market perspective, is that it's a race to the bottom today for cost. I don't think that's a controversial statement at all. I think people know that it's getting priced lower and lower. So we just offered 40 million tokens for free. And I think, in a sense, we can, as a startup, be able to say, hey, actually, our differentiations in tuning the model. So we can actually just offer inference completely free. And so this is essentially a way for us to initially get customers and initially get them started and then future-proof them as well, enable them the flexibility to be able to then create, use these models, but also improve them over time for those future use cases if they are only on inference today.
Could you map the inference market for us? Like who does what? There seems to be a number of different companies doing different things. I'm thinking of Together. I'm thinking of Modal, this open source project like VLLM. Who does what? Yeah,
I'll map that out and kind of focus on like what are the key differentiators. So one key differentiator that I think we often see on benchmarks is around latency. So latency is how fast the model responds to a single query. And that makes it so things are real time when you chat with ChatGPT, and that can move faster. Unfortunately, I think what people don't realize is that the way to get better latency, like significantly better latency, is actually in the hardware. And that's why we see Grok, G-R-O-Q, be able to exceed all these GPU-based inference platforms significantly, by a significant margin. And I think I saw in a VentureBeat article about 280,000 users now using that. So props to them for getting that there. So I think for latency, if you want to compete with speed of the LLM's response to you for a single response, then that is you need to compete at a hardware level. The next thing is around security. I think security is interesting because are you running it on a cloud, right? Or that someone else is managing for you? Or are you running it on your own GPUs? Whether that be your own GPUs in a VPC or your own GPUs on premise, right? So I think that there's a distinction there of what level of comfort do you have in sending data over to another party. And I think I see AI natives and startups largely using the hosted solutions. So managed solutions, we have one as well, kind of on the cloud to make it very easy for people to test out. And then also...
and that's the Togethers and the Modals?
The Togethers and the Modals of the world.
Yep.
And then on the other side of things is being able to deploy that stack on premise or in any hybrid environment and be able to fully control that and have visibility through that. And so we also do that. That's our main way of deploying things. But essentially, you can think of that as I think Nvidia's NIM server, Triton Inference server also does that.
Yep.
And so I think these are all powerful ways of getting high performance. VLLM is an open source project that does that for high performance as well.
Yep. And how does that work for enterprise customers? So, in a world where you have like massive GPU shortage, like they need to procure their own GPUs and then run an inference platform like a Lamini to and bring their own models. Are they? I guess that's what you do for them. But like, how are they able to get the GPUs they need? How does it work?
Today, actually, I'm seeing the GPU shortage go away at the company level, meaning companies are able to procure enough compute. Enough is a strong word, but they're able to procure compute at some level to work with, to fine tune and run heavy inference jobs for these models. However, I think individual teams, that varies, right? Being able to get it from one business unit, get it from central IT. I think there's still a process there. It's kind of like getting data access. Compute access is also gated in a way that is variable across companies, I would say.
Okay, but if you're a large company, like just
bank,
play back, if you're a large bank or Pfizer or whatever, today in July, whenever we're recording this, July 12. 2024, you're actually able to get GPUs.
Yes.
Because we're in a world where there are announcements about VC firms, which I think are a very smart strategy, but like this stockpiling GPUs and all those things. But what you're seeing in the market is actually, if you're a large enough company, you do have access to GPUs.
Compared to last year. Last year was, at this time, was absolutely insane. That's why we threw up our own cloud, because there was just like large companies with multi-billion revenue numbers could not get a node from AWS, despite their accounts being tens of millions or hundreds of millions with AWS. And they said, I got one node for 1 month. That's what my rep said. And I thought, okay, well, that's not great if that's C-suite asking the rep. There's probably something wrong here. So that's no longer the case. I think people have far more compute. Still probably not enough compute to satisfy demand, but it's not totally blocked. It's not in that ridiculous state anymore. And I think there's a graph of this showing that A100s in particular are pretty available. Obviously, the AMD chips that we also agnostically work with, the MI300 and MI250s, those are available. H100s still kind of a little bit harder to get, but you can get started very easily with any of those other chips.
Okay. And you mentioned the GPU agnostic part of the business. So You've been working with different types of GPUs, but last year a part of your positioning was to also work with AMD. So what's the update?
100%. Yeah. Well, today we did announce something with Nvidia.
Just today.
Yeah, just a few minutes ago.
It's like the Mad Podcast, breaking news.
Exactly.
We're now a news organization. Yes.
Well, we put that out with Nvidia, which is awesome. We're really here to make it easy for developers and people building on this technology to be able to have a way to not have to edit their code at all and be able to run agnostically and scale agnostically on multiple types of compute. I think that's going to be extremely valuable moving forward. And I see that as for advanced organizations, I see them doing it today. I think for many organizations, that will be an emergent value prop for them as they scale.
Okay. All right. So let's say I'm a large customer. I'm a Lamini customer. I bring my own GPU. I get access. and then you enable me to then bring my own model, or you have open source models built into the platform? Let's say I want to use Mistral. Is that built into Lamini?
Yeah, we have Hugging Face's model loader integrated. Okay. So any LLM, open source LLM there can be used, downloaded. If you're online, you download it automatically from Hugging Face. If it's an offline kind of deployment with no internet, we download those beforehand, or there's a shared file system you can put those models into. We have a few companies who are pre-training their own models and using those, and then fine-tuning. But yeah, for the most part, fine-tuning is taking a pre-trained model, a foundation model, and adjusting its weights further. But taking something off the shelf is a very reasonable place to start because, Zuck decided to put in billions of dollars up front for us, and we can reap the benefits of those savings.
Thank you, Zuck.
Yeah, thank you. Thank you for the potential scorched earth method of my LLM strategy. Keep at it. I do hope he keeps at it.
While we're at it, talking about definitions, you mentioned pre-training. What is pre-training versus training?
So pre-training is a form of training, actually, and I think people often think of those similarly today for LLMs. But essentially, it's getting the LLM to read the entire internet one word at a time or one token at a time. And it's just auto-completing the internet, right? And so that's what it's tasked to do. It doesn't know really how to answer questions. So if you ask it, what's the capital of France? It's going to respond, what's the capital of Spain? Because it thinks it's in maybe a survey context. And so after pre-training, most foundation model companies, for example, like Meta with Llama and OpenAI and Anthropic, they will do something called instruction fine-tuning, which is teach the model how to follow instructions so that when you ask what's the capital of France, it will say Paris. And so getting it there so that it's chatting with us. And then the next step we often take customers is memory tuning, because it's not a general skill for the model. It's more so specific to your data. So to be able to embed facts of your data into the model, so memory tune the model so that it can recall those facts almost deterministically within its probabilistic context. So that's kind of the last step there. And then, of course, with Inference, you can apply RAG and prompt engineering on top of that model in any of those stages to be able to adjust it to in real time to be able to output something that you need. So that's kind of the layout of how these models are tuned and trained and adapted and turned into these magical systems that we use today.
Okay, fantastic. So still talking about Lamini in the enterprise, we got the GPUs, we got the models, we touch upon the data a little bit through RAG. The output is what? It's a JSON that people can bring into their applications. What comes out of Lamini?
Oh, what comes out of Lamini? So we are a stack.
I mean, magic, of course.
No, not magic. Actually, I want to make sure it doesn't feel like it can feel magical, but hopefully developers can dive in and actually understand mechanistically what's going on. So our customers are able to fully own their models, right? We don't own the models at all. We're just the engine that runs it, similar to, you can think of it as a Databricks or Snowflake model of compute, like being able to manage that compute. We're a stack on top that people are able to install on top of Docker, Kubernetes, or even bare metal compute. And developers are able to interface with it through familiar REST APIs or optional Python client, et cetera. And so be able to actually work with these models locally or in whatever environment they're in, be able to adjust them and be able to then run them at scale.
And maybe to close on Inference, I'm reading right now that Lamini delivers 52 times more queries per second than VLLM, which we touch upon.
Yeah.
What's the secret sauce?
Yes. So a huge part of this is around being able to fully utilize GPUs. I think what we found was a lot of the open source packages out there, while incredible, and I root for those teams every day, they're not necessarily optimized in the multi-GPU case, multi-GPU scenario. So if you're using more than 2 GPUs, which nearly everyone I know is, then fully utilizing the GPU is actually incredibly important to eking out every bit of it you can. This is a very expensive piece of hardware you just bought. If you're only using a small percentage of it, and you're running open source, it actually is more cost effective to run to pay us to install the inference, right? And to run that at high performance so that it is fully utilizing your GPUs at scale for more than 2 GPUs. So I actually find that dichotomy pretty interesting. So throughput is, you can think of it as batch latency. It's essentially how many queries you can put in. It's slightly separate from latency itself of a single query. But that, again, is, I think, a way companies are differentiating today as well. And on inference, actually, I think the final thing that people are highly differentiated on is close to something, with function calling. So being able to output structure is really important to programmatically use these LLMs. So developers really love it when you can output, something that is 100% schema accuracy, 100% like format faithfulness, essentially, from the model, be able to output a list of ints where all the ints are my product IDs or are my user IDs, right? So being able to make sure that it can actually output that right format so that I can then use it downstream for something else, especially in agent case, for example. So that's something else we offer through our inference service to actually make it 100% by re-engineering the decoder of any LLM.
Great. Memory tuning.
Yes.
We alluded to it. It feels like you all had a major breakthrough in terms of research.
Yeah.
What is it? What does anyone need it? And how does it work?
Yes. So maybe stepping back, these models are, pretty good at everything, perfect at nothing. And it's because they're trying to, they're reading the whole internet. They're trying to just reduce average error over everything. But average error means you're not actually perfect at those facts. And it turns out we actually want something closer to deterministic on those facts. And so how do we mix what is probabilistic and really good at understanding similarities, where we want hi and hello to mean kind of the same thing? But we also want those facts to be absolutely perfect, where if you get, your birthday off by a day or two, that's a major issue. If you get your revenue number off by 0, that's a major issue. But from the model's perspective, it's not. So how do you make sure those, for those facts, those specific facts to your business or otherwise, there's no alternative for the model. And so memory tuning does that. It essentially, we say, brings the loss to 0. So it brings the loss to 0 on all of these facts so that there is no alternative. It cannot even pick something that is similar. So something slightly correct is incorrect, as opposed to being, kind of similar. Let me maybe consider that. So memory tuning is a technique to do that. It's very computationally expensive to run memory tuning. So we've essentially optimized it so that it is computationally feasible. And this might get a little bit technical, but turning an open source model, any kind of open model, and tuning the adapters, so tuning like a LoRA, QLoRA, et cetera, on top of the model, and tuning it in such a way that it's a mixture of experts. So a mixture of expert adapters. I think there's been a trend of mixture of experts. GPT-4, Mixtral are all a mixture of experts. Those are 8 experts so that you can train a bigger model, but then when you run it, only uses part of the model, one of the experts, on 1/8 of it. What memory tuning is doing is taking that to the extreme and doing it on the adapter side of things, so doing it on top of the model with LoRa's. And we tune these memory experts, and we have 1 million memory experts or more, right? And so the idea is, like, instead of 8, now you have 1 million, and you essentially get a heavily sparsely activated model. So you can get you can scale the model to be incredibly large. I even think there's a future where these models can be 100 billion parameters, but have that intelligence of 100 billion parameters, but then have the speed, latency, and cost of something that's still 1 billion or 7 billion parameters. So very, very fast because it's only using part of its brain, right, when it's responding to you. Kind of like how we operate. So I think that's a trend, and we just took that to the extreme, and it's highly effective for bringing that loss to 0 in a reasonable amount of time, such as a couple hours.
Okay, fantastic. So you cannot resist again to make this interesting to a broad group of people.
Yeah, please.
With your academic hat on. Let's do 45-second definitions of some of those terms. So let's say what is LoRA?
Oh, LoRA. Okay, so when you tune a model, so you have this giant model, right? And if you want to tune all of the weights of the model, which is traditional fine tuning, very expensive, very heavy to like change, do all those, multiplications, additions, et cetera. So that's very, very expensive. LoRA is a efficiency technique to make fine tuning extremely efficient. It's part of the category class of parameter efficient fine tuning, PEFT. And instead of training all those weights, all those parameters, you can tune only a subset of them. Not a subset, an external set of weights instead. And then at inference time, fuse those weights using, I'll just say math, back into the model so that it is the same latency. So it's not just external like extra weights and the model has to like compute all of that when you ask it a question. You fuse it back into the model so it is the same latency when it comes back to you with a response. Right. So it's an incredible technique. I think for something like a GPT-3 level model, it's a 10,000x speed up in efficiency while losing nearly not much at all in accuracy. And for enterprise use cases, that's really not the real bottleneck in accuracy. So we see it as just a performance improvement. And I believe folks are all trending towards fine-tuning with LoRA since it's kind of what makes sense.
And in the same vein, what is mixture of experts?
Oh, yes, mixture of experts. So mixture of experts is essentially, well, let's step back. Before mixture of experts, we have one giant model. Okay, so it's one giant model. And when I ask it, hi, how are you? Every single weight of the model, the entire brain of this model has to like think, and respond, I'm good, thanks. And then if I give it, a really, really, really hard like math question or really, really hard patient diagnosis, it will also have to use all of its brain and then give me the diagnosis, right? And so that doesn't seem to make any sense to do that. That seems like overkill. So mixture of experts is getting at the sense of, okay, well, how about we have maybe, 8 is a common number, 8 experts instead, and they all kind of come together. They all still train together, and there's a router that routes between them so that when I ask, hi, how are you? Maybe the expert who's just good at like regular conversational English prose will say, I'm good, thanks. And another one who's good at, medicine will give me that diagnosis from the patient. And the benefit of this is that these experts are much smaller than the whole thing. It's only using part of the AI brain, right? Mm-hmm. So that makes it so it's much faster when it responds. It makes it much cheaper when we run fewer computations on the GPU. And it's also much less memory intensive because it's only running part of that model there. So yeah, that's one interesting thing about mixture of experts. And of course, I kind of like seeing this taken to the extreme with LoRa's together. And I do think that's the future, so we can get something that is incredibly smart, incredibly huge, but with the latency, cost, and speed of something tiny. So no more big model versus small model paradigm. It's potentially one and the same.
So back to memory tuning. So is that help us understand? Is that something that's in production today in the product,
yes.
or is that research?
Oh yes.
And if it's in production, how is it working so far?
Yes, so it is in production today for our enterprise customers. It is, we put out a case study with a Fortune 100 company, and they were doing Texas SQL. They had spent 6 to 9 months with 3 data science teams, working with advanced RAG and instruction fine-tuning, as well as prompt engineering, and could get to about 50% accuracy. They had very complex schemas. And with memory tuning, in just a few days, they were able to reach 95% accuracy on their same evaluation set. So very big change, because the exact problem they had was that the model was hallucinating on, for example, month ID, 2024-04. Turns out the model, you could not get it to say anything but April, but for their database, it was January, right? Maybe there's a fiscal year thing going on, right? So it's very custom to that company, and they could not, with as much RAG, as much, please, 04 means January, could not get the model to do that. So this is actually enforcing that inside of the model. And yeah, it's very exciting, and I'm seeing I'm seeing basically a new frontier of accuracy emerge for these models and for use cases for enterprises. And so that'll be really exciting. I think there will be completely new use cases emerge from this that are now possible, that were impossible before. And it's at a lower cost and latency. So that'll also help with getting real ROI on these use cases.
Yeah, I mean, that feels like an absolutely huge breakthrough, right? Hallucination has been the main issue, and if you could get to that level of accuracy and make things like text to SQL actually work. That is an incredible. Congratulations on that. Okay, so and the trade-off you said is you've made it computationally feasible, but it's still computationally intensive.
Yeah, so I would say today, memory tuning is probably easier than advanced RAG, but still harder than simple RAG. And from a speed perspective today, it's still a couple hours, like 2 hours, to be able to run a memory tuning run, whereas building a RAG index is on the order of minutes. So we're working on bringing that number down to minutes so that it feels like building an index. And memory tuning, to be clear, is actually super inspired by not necessarily RAG, but the same parent area called information retrieval. And it's essentially putting that information retrieval piece inside of the weights of the model, and in a way that is extremely efficient for that AI brain to retrieve those right memory experts for the right facts that they're trying to respond with.
Okay. So the other big theme that everybody's talking about in the enterprise these days is agents.
Yes.
Where does that fit in the Lamini vision, and what are your general thoughts on the world of agents?
Yeah, I think spicy topic. So I think so we support a lot of agent use cases today, and obviously the LLMs behind running those agents. The case studies on a SQL agent, right, able to ping a database with the SQL it's generated and be able to respond back to the user. My view of agents is that it's kind of just like it's kind of object-oriented programming, where it's taking a different center. Instead of looking at each LLM call, it's saying, okay, here's something that is almost like something I understand, like an object or a person, and being able to say, okay, it can do all of these tasks. And all those tasks are LLM calls. So I kind of think of an agent as something that does more than one LLM call and is like thinking about it from this center of gravity of like, how person-like can I get this so that I understand it in my worldview? It's interesting because historically, AI researchers, we haven't really thought about it from the lens of agents. I think that really has emerged from the community of both developers and because I think code agents became incredibly interesting and hyped up just a little bit. I think from like a marketing perspective, I actually think it's and an explainability perspective, I think it's actually incredible because it explains, how people view the world and what the AI could do. Now there is a gap between what it can do and those goals and potential fantasies. So I think bridging that gap is probably an important piece of it, and understanding that at the end of the day, the most computationally expensive and the most important piece of that agent is the LLM. Like that is the hardest piece of it. And I am a little bit worried about those who call an LLM like 30 times within a workflow and still expect real-time latency on them, because realistically, that's probably not the approach you want to get if you expect your agent to be, real-time like a person, and then you do 30 LLM calls, which are all highly requiring extremely high intelligence to be able to understand what's going on. And so I think there will need to be specialization. And we've started seeing people both memory tuning and fine tuning these models. So then instead of 30 calls, 3 calls, or even 1 call to make it much more real time.
Mm-hmm. And is that a question of it's just too computationally intensive and therefore expensive and then slow? Or is it a question of the error, the potential hallucination compounds, or is it both?
It's both of those things. Yeah. And I think people are addressing error today by adding more calls to the model, of filtering out the requests. And I think I don't think that'll work for serious production use cases. It makes it harder to work with that entire blob. But for prototype, I think it's perfect. I think it's great. Yeah.
Okay.
Like show that it is doable or almost doable, right? I think that actually is able to help you get the right data to then maybe even fine tune or adjust the model to do it in one shot, in one call.
Okay. Mm-hmm. All right. Well, it's been wonderful. Maybe to close, what's next at Lamini? The next few months or year until you come back to the Mad Podcast.
Until I come back?
Yes.
Oh, what are my predictions of what I'll say next time?
Yeah, no. Well, hopefully we can do this on a regular basis. I very much enjoy those conversations. So, joke aside, what is next for Lamini? All right. Well, it's on record now. You have a permanent invitation to come back. So, what is next for Lamini?
So what is next? I think we want to drop the speed of doing memory tuning significantly because we've seen huge value in the market for this technology, obviously with reducing hallucinations being a major gap in production use cases. But dropping the speed, I think people sometimes think, oh, performance, whatever. Serious drops in speed and in performance result in the ability for completely new interfaces and tasks. So if instead of hours, it takes minutes, if it takes seconds, I believe in a future where we're continuously fine-tuning these models, where it's as easy as prompt engineering. And these models continually improve. It actually baffles me that when we do text ChatGPT and we give it all this feedback in my conversations with it, that it's not actually adjusting the weights because it is quite difficult to do that. And so to make that significantly easier and then also faster, those are two important pieces of bringing that future out. And I think that is the full capability of these models. Because today when people are running RAG or prompt engineering, those are search. That's not AI. It's like keeping the AI frozen and fixed. And so I'm curious about a world where the AI is able to continually evolve with us, just like we learn. It's not like our brains are not plastic, right? So a brain that's plastic is going to learn much, much more versus just be kind of adjusted at a local scale. So I'm excited about that. And I think, I'm excited to see that actually come to light. And I see people starting to do continual fine-tuning in a way that is maintainable. So to keep models refreshed and up to date.
And are you, while we're on the topic, are you in the camp of, ultimately we needed to add reasoning, symbolic part, to the raw power of LLMs?
Or is it just data and compute?
Yes. Where are you on that debate?
I think part of my heart wants it to be that way, where we understand enough that we can symbolically include something in there. But my sense today is there's nothing that's convinced me that is good at that enough. Instead, the new architectures that come out that are essentially better are all about taking advantage of compute better. And that is what transformers were. And that's what some of the new models coming out are, and new architectures are as well. So I'm excited to see what the future bears. But I don't think it's going to be the exact architectures and how we frame it, how we understand it today. I'm one in particular that I'm interested in is I used to study diffusion models. This would significantly reduce latency, right, by a very large margin. So I'm interested in seeing. I don't know. I saw like a mass diffusion for text generation that was very promising in the research realm, and so kind of curious about that. Improvements that are not necessarily incremental. And when fields kind of collide, I think there's new things that happen.
Great. Well, fantastic. Sharon, thank you so much for doing this.
Thank you so much for having me again.
Hi, it's Matt Turck again. Thanks for listening to this episode of the Mad Podcast. If you enjoyed it, we'd be very grateful if you would consider subscribing if you haven't already, or leaving a positive review or comment on whichever platform you're watching this or listening to this episode from. This really helps us build the podcast and get great guests. Thanks, and see you at the next episode.